June 13, 2013, the Williams Geismar Olefins plant in Geismar, Louisiana, a heat exchanger violently ruptured, causing an explosion and fire that killed 2 workers. The Chemical Safety Board launched an investigation and issued a case study. In it, the agency describes a number of process safety management program deficiencies at Williams, which set the stage for the incident. In particular, the CSB found that the heat exchanger that failed was completely isolated from its pressure relief valve. When pressure inside the heat exchanger dangerously increased, there was nothing to stop a catastrophic rupture.
Our case study on the explosion at Williams describes an ineffective process safety management program at the plant at the time of the incident. We urge other companies to learn from our investigation, to incorporate our recommendations at their facilities, and to assess the current state of their process safety culture so that a similar accident can be averted.
The Williams Geismar Olefins plant is located in Geismar, Louisiana. The plant produces ethylene and propylene. These are chemicals used in the petrochemical industry to make a variety of products, including plastics and antifreeze. Within the Williams process is a distillation column called the propylene fractionator. It separates a mixture of propane and propylene. Heat exchangers called reboilers supply heat to the fractionator to boil the propane and propylene mixture, which is essential to the separation process. The reboilers are shell and tube heat exchangers. Hot water flows through the tubes, heating and vaporizing propane that flows through the shell and back to the propylene fractionator. The water that flows through the tubes contains a small amount of oily tar, which condenses into the water earlier in the process. Over time, the oily tar from the water builds up on the walls of the reboiler tubes. This buildup is called fouling. Fouling reduces the efficiency of the reboilers. Periodically, the reboilers must be shut down to clean the tubes. The original propylene fractionator design had both reboilers running simultaneously, but in that configuration, the fractionator had to be shut down when a reboiler fouled and needed cleaning. To prevent shutdown of the propylene fractionator each time the reboilers needed to be cleaned, in 2001, new valves were installed on each reboiler to allow for operation of only one at a time. The other reboiler is on standby, clean and ready for use. But unforeseen at the time, these valves introduced a serious hazard.